Hello and welcome to the lecture for section 2.5. It is the last section in chapter 2 that we're going to cover, and we're going to talk about changing our graphs. So last time we talked about different shapes of graphs, and this time what we're going to do is we're going to manipulate that on a graph and move it around and squish it and stretch it. So what we're going to do today is we're going to look at horizontal and vertical shifts. We're going to use compression and stretches, and then we're going to look at how to reflect the function about either the x-axis, so reflecting it over that horizontal line, or the y-axis, which is that vertical line. So we're going to look at these three different ways to manipulate your graph. So the first one, let's go ahead and look at using vertical and horizontal shifts. The best way to go about actually looking at this is to do an example. So here's our first example. We've got a graph of f of x equals x squared, and we're going to use that to get the graph of g of x squared plus 3. Okay, after we do that, we're going to find the domain and the range of g. So let's first start by making a table and looking at some points on the graph. So here, let's do x, let's do f, and let's do g. Let's just pull out like 3 to start. The first one we're going to pick out, let's do a negative, so let's do -2, let's do a 0, and let's do a +2 for x. Now, if I take f, which is x squared, if I square -2, I get a +4. If I square a 0, I get 0. If I square a +2, I get a +4. Now for g of x, I'm going to take that, I'm going to add 3 to it. So 4 plus 3 is 7. 0 plus 3 is 3. And again, 4 plus 3 is 7. So here we have a table a little bit more readable than my handwriting. And it also has the -1 and the 1. So this is going to be all the different points on the graph. Now, if we notice, all the values of g are just increasing by 3. We added 3 to them. And that the y-coordinate is going to be 3 units larger than the original y-coordinate. So the graphs are going to be identical, except that it's going to be shifted vertically 3 units, because the y is changing by 3 units. So let's go ahead and look at what the graph is going to look like. Okay, so we've got, I'm going to graph the original first. So we've got 0, 0, we've got 1, -1, 1, and 1, 1, and then 2, 4, and -2, 4. So what we've got is we've got something that looks like that. Our original graph, okay? That one is going to be f of x. Now, let's go ahead and take the minute and graph our g of x. So we've got -2, 7. We've got -1, 4. We've got 0, 3, 1, 4, and 2, 7. So here is my graph of g of x. Okay. Let me put on my nice graph that looks way better than mine. The next thing we can do is find the domain and range. The domain is going to be all numbers, because remember, domain's on that x. So we're going to go from -infinity to infinity on this. These are, we're just going to keep going on either side. The range, on the other hand, is going to be everything above this line, because we're doing the range of g. This is of g of x, not of f of x, okay? So the range is going to be all y's, including 3, going up to +infinity. Okay? Because we can see we're only going up there. And what we did is we moved this right here by those 3 units. Okay, we added 3. Now let's look at the other hand. Let's see if we can make it go down. So we're going to do the same thing. We've got an x squared, and here we have x squared minus 4. So we did a plus 3 last time. We're going to do a minus 4 this time. If we make our table of values, okay, our x squared is going to stay the same as what we had before, but this time let's do the x squared minus 4. So we've got 4 minus 4 is 0 for that. 1 minus 3, 0 minus 4, 1 minus 3, and 4 minus 4. Okay, you can see here what we've done is we have subtracted 4 from every single one. So we're actually going to move down 4. Remember, we added 3, so we went up 3. This we're going to subtract 4, so we're going to go down 4. Let's go ahead and do our f of x. So we've got 0, 1, 1, negative 1, 1. 2, 4, negative 2, 4. And we're going to make our smiley face. My f of x. Now, if I graph the g of x this time, I can start with my 0, 0 point, and at this time it is 0, minus 4. I'm at 1, negative 3, and negative 1, negative 3. And then at my 2, I'm actually at 0. So 2 and minus 2 is at 0. I can go ahead and make my smiley face like that. And that's going to be my g of x. Okay. Again, I'm going to put a better picture on here for you. There we go. And we can see that we have gone down those 4 units. So from the origin down to here. For g of x, let's look at the domain. Okay, we are going from negative infinity to infinity. We didn't change anything on that domain. But the range, on the other hand, is going to be slightly different. The range of g of x, which is the blue, is going to go from negative 4 up to infinity. Okay. So we shifted down by 4 units. So let's take a look at some notes to take regarding shifting our graphs. So if we have a positive number k added to the output of the function, it's going to shift vertically up k units. So for our example 1, we had 3 units. It was a positive 3, so it went up 3 units. Now, if a positive real number k is subtracted from the function, it's going to shift vertically down k units. So for our example, we had a minus 4. So we shifted down 4 units. So if y equals f of x plus k, it's going to go up vertically. And y equals f of x minus k is going to go down vertically. And we're going to use that k as our starting point. Now, what if we want to move it left to right? Let's take on the next example. So for this, we're using an f of x going to be the square root of x, and our g of x is the square root of the x minus 2 in a whole, okay? The minus 2 is not on the outside of the square root, it's underneath the square root. So let's find some values in a table of x. So here for square root of x, I can go 0 to 0, 1, 1, 4, 2, 9, 3. That's just finding the square root. That's this first one right here. This is going to be my f of x. On the other hand, I can put in values of x and get your other value, your y, for your g of x. Now, for g of x, again, remember, we don't want a negative in there, but we can start at where it equals 0. Okay, so if you notice, the y's are going to be the same. So start out where it equals 0. Well, 2 minus 2 is 0, so it's going to be 0, 2. Okay. at 1. Okay, we want to know where, so what we're doing here is we've got 1 equals the square root of x minus 2. Okay, that's how we're trying to figure this out. So my x is going to be equal to 3. Okay, the other way you can look at it is for the second part, you can say y equals square root of x minus 2, square both sides. Your x is going to be y squared minus 2. Okay, now we've got the y squareds, and so we figure out x squared. So it's a little bit backwards. Let's go ahead and graph it. Let's graph the f of x first. So we've got points at 0, 0, 1, 1, 4, 2, and 9, 3. And we remember from last lecture that it's kind of like a half U going up. Okay. Now, what we'll do is let's do g of x. So we've actually got 2, 0, 3, 1, 6, 2, and 11, which is way out here. 3, 1, 2, 3. And we've got g of x here. Okay, now notice that the x coordinates on the graph of g are 2 units larger than the corresponding ones for the f. So 0 plus 2 is 2, 2 plus 1 is 3, 4 plus 2 is 6, 9 plus 2 is 11. Okay. Now, therefore, your g and your f are going to have identical shapes, except that your g is going to be shifted horizontally 2 units to the right. Okay, let's get a better picture of that so you can get an idea of what that looks like. So you can see it's shifting, everything is shifting to the right plus 2. Now remember, we're going to do g of x. The domain is going to be everything greater than 2. Okay, because we're starting here. Okay, so 2 to infinity. The range, on the other hand, is going to be 0, infinity. Okay, because we're still, everything's 0. Okay, so all you've done is shift it 2 units to the right. So how do you think we go to the left? Okay, we're going to use the square root again. But notice this time we're adding 4. Remember, we subtracted 2 just now. Now let's add 4. So doing the same thing we did before, let's graph what our square root of x looks like. Our little happy face and my terrible drawings. Now, we're going to shift it to the left. We're not going to do the table this time, but let's go 1, 2, 3, 4 to the left of this point. 1, 2, 3, 4, and 1, 2, 3, 4. It's supposed to be straight. It's supposed to be curved. That's going to be g of x. Okay. Again, let me get you a much better picture because my drawing skills are terrible. Now, here's my start point right there. So my domain is going to be what? -4 going to infinity. Okay. And my range is going to be 0 to infinity. Okay. From -4 to infinity, from 0 to infinity. You can see each point has moved to the left 4 units. Again, let's take some notes on what we just did. So if we have a function with the x being replaced by x minus h. So it's a little bit different this time. Before we had minus to the left, plus to the right. This time, if we have y equals f of x minus h as a whole is going to go to the right. On the other hand, if your function f is replaced by x plus h, such as on the bottom here, then it's going to go to the left h units. Okay, so when it is within the parentheses of the function, so your x is moving, it kind of flips the sign. So if it's a minus h, you're going to go to the right, you're going to go towards the positive. And if it's a plus h, you're actually going to go to the left, towards the negative. Let's do one example of where we're going to attempt to, let's combine them. Okay, so we're going to graph this in steps. What we're going to try to do is graph f of x equals the absolute value of x plus 3 minus 5. And then we're going to find the domain and range. So first, let's graph f of x as the absolute value of x. We remember from last time that it is this v with the origin point at 0, 0. And oh, that was a squiggly straight line. Now, the first thing we see, if we can look at this, we have, so that is absolute value of x. I'm just going to label them so that we can tell. Now here, we're affecting the x. Okay, that was the theorem that we just looked at. So that's going to go left to right. Okay, it's going to go 3 spaces, and it's plus 3, so it's going to go to the left 3. Okay? Let's graph that little piece just by itself. So let's go 1, 2, 3. There's my new origin. Again, I'm going to try to graph a little better. Okay, we moved it to the left 3 spots. Next, let's look at this. So the one on the outside that affects the y, that's the up and down, we're going to go 5 units, and it's a minus 5, so we're going to go down 5 units. So we're going to take the one we just did and then move it down 1, 2, 3, 4, 5. Okay. And draw our V. Okay, that right there is going to be your x plus 3 minus 5. Okay, that is your final one that you want to see. Okay, I'm going to break it up into 3 separate graphs so you can see a little bit better what's going on. So, for example, we just drew absolute value of x. That's this first one, A. Okay, it's a V. We've got a few points. Remember, the vertices is at 0, 0, and it's going to be like 1, 1, negative 1, 1, 2, 2, negative 2, 2. Now, the first thing we're going to do is replace it by the x plus 3. That's going to move it horizontal 3 units. Okay, so we went to the left 3 units. So our 0, 0 point is now at negative 3, 0. Okay. So we're moving that x component by 3. Last but not least, subtract 5 from the total, which is that vertical shift, down 5 units. So down 5. Okay, so our vertex that was at 0, 0, so that vertex is now going to be at negative 3, negative 5. Okay. You can combine any of these shifts in any ways to move these graphs around, but remember, they're just shifts. The shapes are going to remain the same. So since this C is our final, let's look at the domain of that. Okay, and for this, we're going all the way from minus infinity to infinity. And the range is going to be everything above negative 5. Okay, because our minimum point here is at negative 5. Now, let's take a look at how we can actually change the actual shape of it by either compressing it or stretching it. So again, we're going to look at an example. So we're going to start by creating a table of values for g. So our f of x is square root of x again, and we're going to use that to actually graph 2 times the square root of x. Okay, so this time our number is outside of that square root. We're not doing anything inside, it's on the outside. Let's do that table of values that we traditionally like to do. Let's pick some x values of 0, 1, 4, and 9. We know the square root of those numbers. And then to get from f to g, all we're going to do is multiply by 2. Okay, so we can see that for each x, g of x is 2 times as large as what f of x is. So let's start out by graphing our f of x, and that's our u. That goes like this, 1, 1, 4, 2. It's going to be like our half of a u function. That's our f of x. And then let's plot some of those points for the g of x, and then we'll connect those dots. So we still have 0, 0. That's a terrible line. It didn't even meet the point. Okay, so we still have 0, 0. That didn't change. Now we have 1, 2, 4, 4, and 9, 6. So what we're going to do is our graph. Okay. Let's take a better look at what it actually is going to look like. You can see here we stretched it up. Okay, it's not evenly just pulled up because 0, 0 remained the same, but it's like it was fixed at 0, 0 and we pulled up on it, so it stretched up. Okay, it's going to stretch it up by a factor of 2 because we've got 1, 1, 1, 2. We've got 4, 2, 4, 4. Okay, we've got 9, 3, 9, 6. So it's a factor of 2. Okay. This didn't ask for domain and range. We're not going to worry about that right now. But let's take a look at how we can compress a graph. So again, let's start out by doing our table. We've got -2, -1, 0, 1, and 2 for x. And this time we are doing the absolute value. So we're going to graph the absolute value of x, and we're going to try to figure out how to use that to get 1/2 times the absolute value of x. So let's start by graphing absolute value. That's that v with our dot at 0, 0. I might be able to do a graph here. Nope, 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 nope. That is a shady straight line. Okay, f of x is there. Okay. Now, all we're doing is we are multiplying it by 1/2 this time. Okay. Last time we multiplied it by 2. This time we're multiplying it by 1/2. You can see the difference there, right? So each value for g of x is going to be half of that for f of x. So our point 0, 0 stays the same. Okay. But say, for example, 2, we're saying 1. Okay. So we're doing this. We're a little bit squished now. Okay. So it's held steady at 0, 0, and it's like you push the two sides down and make it flatter. Again, much better picture than what I can do, but I try my best. You try your best and you don't succeed. You're probably too young to figure out that reference, but that's okay. So, okay, multiplying by 1/2 actually is going to stretch that function by a factor of 1/2. So, for example, now the point was a 1. I mean, I'm sorry, it was a 2, it's now a 1. The same thing here, it was a 2, it's now a 1. It's half of what it was before. Let's take some notes on what we did about this vertical compression. So when the function f of x is multiplied by a positive number, as long as a is between 0 and 1, it is compressed. Okay? By compressed, we mean that was that second one. If you're multiplying by anything less than 1, so that 1/2, it compressed it, pushed it down a little bit, made it a little wider. Or it's going to stretch it and pull it up if it is greater than 1. So that was that first example that we did, okay, where we multiplied it by 2 and it kind of stretched it up a bit. Now, in the same way, we can find that we're going to have a horizontal compression or a horizontal stretch. We're going to see in just a minute by example. If we take that A or that number and we put it with the X instead of basically the Y. So if we have a function Y equals FA of X, okay, if it is a horizontal, if A is greater, it's a horizontal compression if A is greater. It is a horizontal stretch if it's a fraction. Okay, so just take that and put that in your notes. We're going to look at an example right here in just a second. Here, we're just going to have a generic function of Y equals F of X. It makes a curve here. So the first thing we want to do, I'm going to do two different things. I'm going to do Y equals 2F of X, and then I'm going to do Y equals F of 3X, okay? One is going to do a horizontal compression, and the other one is going to do a horizontal stretch. So let's look at the first one. Here is my original equation, f of x, over here on the right. And on the left, what we can see is y equals 2f of x. One thing you can see here is that originally I went from 1 to -1, and now I go from 2 to -2. So we took this and we stretched it. Okay, we stretched it by 2. Okay, so we were 1, we're now 2. We were -1, we're now -2. Now let's look at the other one where we actually put the number inside the parentheses. So y equals f of 3x. Now here you can see there wasn't any change here in the amplitude. Your change is actually here. That's the original. So we took it and squished it. Okay? So we squished it by 1/3. Okay? So what was 3 pi is now pi. So it's 3 pi times 1/3 equals pi. Okay? So it's squished by 1/3. Last topic we're going to look at today, and then we're going to do a few examples about combining. But what we're going to do first is we're going to look at how to reflect about an axis now. Okay, so we've shifted up and down, left and right, we've squished, we've stretched in both horizontal and vertical. So now let's reflect about the x-axis, and then we're going to do a reflection about the y. So let's start out with the graph of y equals -x squared. We're going to find the domain and the range of f. So let's start out by figuring out g of x equals x squared, and then we can take the negative. So if we make our table and we have our x's and y's, here's our traditional x squared, and then all we do is we do a negative of it. So let's plot all of those. Our original graph is going to be 0, 0, 1, 1, 2, 4, -2, 4, and we're going to do our happy face, okay, which are really bad. Okay, and here I called this g of x, just to keep them straight. Now, what I'm going to do when I plot f of x is, you can see it, I'm going to keep this origin the same, but I'm giving it a negative. So it's going to be negative, and then 2, 4, 2, 4, and we're going to make it a frowny. base. So you can see we took the x-axis there and we went from up and we just flipped it. Again, I will save you my lovely drawings. Anyway, from here we can find the domain and the range. So our domain is all real numbers, so minus infinity to infinity. And now our range is going to be from 0 below, right? So now we have to put 0 on this side. Minus infinity to 0, because you're actually going from minus infinity to 0. Okay? Let's look at the reflection about the y. Here we've got square root of negative x, and let's use the square root of x to find out what that would be. Okay, so we're going to start out with the point 0, 0, and our square root looks like the half of a u. Okay, probably not even close to being close, but we're going with it. So now for each point, what we're going to do is do the negative of the x. Okay, so 0, 0 stays the same. And what we end up doing is going that way, about that y. Okay, so that's reflecting it about the y. Let's get you a better picture. Now for this, remember we're looking at the blue here. So the domain is going to be from minus infinity to 0, right? From minus infinity to 0. And the range is going to be from 0 to infinity. 0 to infinity. So to reflect about the x, you do the negative. To reflect about the y, you do the negative x. Again, something for your notes. When the right-hand side of the function y equals f of x is multiplied by a negative 1, so the new function looks more like y equals minus f of x. It's the reflection about the x-axis. When you graph the function y equals f of x is known, the graph of the new function y equals f of minus x, notice where your negative sign is, that's going to be a reflection about the y-axis. Last but not least, let's do an example of where we're going to combine a whole bunch of these things, and we're going to take it step by step. So first of all, we need to rewrite this equation. And what I want to do is I want to pull a 2 out of that fraction because I can do, I can pull that 2 off of the top and I can get 2 times x plus 2 on the bottom. So I can do something like this. F of x equals 2 times x plus 2 minus 1. Okay? That's what I want my equation to look like. So what I'm going to do is first, I'm going to graph 1 over x. Then step 2, I'm going to do the multiply by 2. So I'm going to do 2 times 1 over x. Okay. Step 3, I'm going to add that 2 back in. And then finally, I'm going to subtract the 1. Okay, so I'm going to make 1, 2, 3, 4 graphs. Okay, step by step, baby steps. Okay, so let's go for it. We can do this. For the first one, what we're going to graph is 1 over x. So the graph of 1, oh, look at this, 1 over x. The graph of 1 over x is going to look like this. Now we kind of did it, the shape of it yesterday. We're going to kind of look like that. That's our y equals 1 over x. Okay. Now we're going to multiply that by 2. So what we're going to do is that's going to do our vertical stretch. Okay. And so what that's going to look, it's going to look more like that. That looks exactly the same. This is probably more closer to there. Enough of my terrible drawing skills. Ta-da! Beautiful! So much better than mine. I apologize for my drawing skills. Okay, so now we've got step 1 and we've got step 2. Let's take it the next step up and we're going to multiply or add that 2 back in. So let's move the graph of that and let's put it back in. Okay. Now what we're going to do is we want to add 2 to the x. Okay. Because this is 2 over x. So this one is going to be 2 over x plus 2. In order to do that, it's going to be a horizontal shift to the left 2 units. Okay? So a good way to do it is that this, where's my 2 line? There it is. Okay, that's kind of, your axis is now going to be moved over 2. And what we're going to have is something that looks like this. Okay? This stayed the same. Your x-axis stayed the same. Your y-axis is now moved 2 over. Again, I'm going to spare you my graphic abilities. And this is a much better view of what it looks like. Okay, we only have one more step. We have to subtract that 1. So let's take the last one that we did. And what we need to do is subtract 1. And what that's going to do is it's going to do a vertical shift down 1 unit. Okay, so here we've got our axis is now here. We're going to take the other axis, we're going to move it down 1. So now our graph is going to look and that is going to be that value. Again, here's the last slide for today. If you take that vertical shift down, you can see it just moves it down so that that x-axis would be like down 1 below. Again, when you get something where it's combined, don't panic. Pull out piece by piece. Remember those notes that we took of what each one of those does and just do it piecewise. Just take it slow and steady and you'll win the race. As always, if you have any questions, reach out to your professor and I'll see you next time.